For links to the audio and video versions of the Industrial Software Podcast, as well as a newsletter sign up, you can always head to ManufactureSoft.com. You can also reach out by email to contact@ManufactureSoft.com. Thanks, and let's get into the show. Hello, and welcome to another episode of the Industrial Software Podcast. Today I have joining me Jérémy from RoboDK. Thanks for joining us.
My pleasure, my pleasure.
Just to get going, why don't you just tell us a little bit about what RoboDK does and what you do at the company?
Yeah, of course. So RoboDK is obviously a software company. We work in the field of industrial robotics. So we do simulation and offline programming for multi-brand. So we are like what we call a brand agnostic software. So you can simulate over 40 different brands. We have over 600 robots in our online library. You can simulate a bunch of different applications, from simple material handling, pick and place, stuff like that, to more advanced stuff like robot milling, welding, gluing, polishing, and so on. And the cool thing about it is that in most cases, when you're done with your simulation, you can convert it into a real robot program that you can load on your controller and run in the field for real. So as you just mentioned, my name is Jérémy. I'm the product manager here at RoboDK. So I've been working here for 4 years now. Been using the software for 6.5 years. The software has been out for 7 years. So I wish you good luck finding someone that has more experience with this software than I do. And I have various roles here. So like I said, officially my title is product manager. So I do oversight or overview some of the technical development. I also take care of all the training material we offer online. I do technical support, some marketing and sales. So anyway, I dip my toes in as many buckets as I can here.
All right, and I also want to encourage our audience, if they are new to RoboDK, there's no real barrier to entry to the software. I was able to go onto their website, download the software, start poking around, pulling in, 3D models of cobots and moving them around in 3D, as well as if you want to get familiar with the company and the history behind the company, they have tons of great materials on their YouTube. So there's really a wealth of resources to get acquainted with the software. So I'll try and keep us from retreading over ground because you folks have put out so much great material out there already.
Yeah. It's kind of our philosophy to make sure that people have access to as much material as possible, can get going as fast as possible. We can discuss that later, why we exist in the first place. But our goal was pretty much to remove some barrier to entry to robotics in general. So we try to make it easy for people to get started with our software because it would be kind of working against our own values in this case.
There you go. Very successful on that front so far, since I was able to, get my hands dirty already. So, so let's talk a little bit about your customers. So yeah, it's interesting to think of what do they call themselves? I think of that set of folks in this industry as systems integrators or value-added resellers or things like that. How do they describe themselves and think about themselves? If I'm on base on that. Yeah,
you are. But we have we consider we have kind of three types of users, or end user in our case. So we have the actual end users. So there's a bunch of folks out there that try to get involved into robotics themselves. They just buy a robot from a local distributor and they get going with the integration themselves. So that's part of our user base. We also have obviously people that call themselves system integrator, as you just mentioned. So people that already have experience in robotics and want to have other more tools in their toolbox to either we can get into more detail, but either de-risk the process of integrating robots. So for many reasons, robot integration is kind of a risky business because of the custom, or you never kind of repeat the same process over again. It's not like you build one machine and then you just sell a bunch of those machines. Every time you go and see a new customer, it's always kind of a bit different. So this is part of our user base, and we also have people that mostly use it as a selling tool. So either distributors or robot manufacturer themselves. So we have partnership with a bunch of robot manufacturers that do not have a robot simulator in their portfolio. So they use RoboDK as a way to showcase either their robotic capabilities or to showcase the potential end customer, the idea they have to solve their problem or the solution they have for the end customer problem.
Do they do any kind of white labeling of the RoboDK software and offer it as kind of a first-party offering, or is it they kind of point folks in the direction of RoboDK?
Both. We have a bunch of distributors or partners that will sell RoboDK through their channels. So this works for partners that have a bit more of a volume. Let's say they sell a few licenses a year. The more the better, obviously. For other, let's say, integrators that would have maybe 1 or 2 licenses a year or something like that, most of the time they just point it towards us, so it makes things easier for them. They don't have to support the software. We do the support directly. And yeah, so a lot of our customers simply buy our software directly through our website. They never really contact us. They just go to our website to download the trial. So you can download a 30-day free trial directly on our website. As soon as you download the software, in fact, it comes with a 30-day trial. And then they will jump on our YouTube channel, start listening to some training material, and then they will get going. At some point, they like the software. If they do, they will purchase it directly on our website. So that's one type of, let's say, workflow for people to buy our software. Or the other way is like directly contacting us, obviously, or going through third parties or partners, system integrators. We have a list of those on our website that you can check out depending on the country you are in.
And in terms of like the specific pain points that RoboDK seems to be addressing, it's called out very specifically in a lot of your recent blog posts, particularly around the release of your web version, which, if folks aren't familiar, there's now a web version of RoboDK that loads straight into the browser, like no other software download needed. And it's a little bit like kind of a lightweight version of it that's easily shareable and things like that between multiple parties. A lot of that is called out in your blog post as a result of the fact that RoboDK is very valuable during the sales process. Yeah. And I also know from your other podcast appearance that you were saying that was your introduction to RoboDK, if I'm not mistaken, was using RoboDK as part of the sales
as a selling point. Yeah, completely. So if I go back to the beginning of your question, like what are the pain points that we are addressing? I would say there's like 2 types of pain points. So first of all, people generally need to or want to do some simulation to either address their own concern before creating a quote, before starting buying some hardware that, as we all know, like the hardware in our field is quite pricey sometimes. So like you don't want to like drop like $100K on a robot and the things that are around it to realize that it's not the right size. Like you didn't do your reach study, or like you're colliding with a bunch of other material that are already there in your station, stuff like that. So people will use a software like ours to do like reach study, collision detection or avoidance, being able to have like general idea of the cycle time that comes with their process. Also, like another problem that we have in our industry is like we have a very fragmented industry. There's a bunch of players out there, a bunch of robot manufacturers. This is awesome. But the problem is like the more we go, the more companies or like plants will have, okay, they have like one Motoman, and then they have one Fanic, and then they have 2 URs, and then they have a bunch of different robots. Oh, they just realize that they need a super small robot. They'll buy a Mechademic. Oh, that's great. But like, do they need to retrain their whole staff, the whole robotic staff on all of those platforms? Because as we know, they don't use the same language. They don't use the same software. They don't use like, apart from the mechanic that is pretty similar, everything like behind it, like the way you use it is quite different. So that's one of the reasons why we exist in the first place, giving people like one stop or one place, one software to program all of the brands. The reason why we came up with RoboDK for web was to address 2 things. First of all, like you said, like having a quick access to the software anywhere you are. You don't need to be on your computer, on your specific work machine at your office. RoboDK doesn't need a big machine, but people oftentimes prefer having like their CAD machine to run it. So you can just like pop it up on any browser, and we'll take care of the processing power. It, like you mentioned, it's a very light version of RoboDK. You can bring in robots, 3D models, and then create very simplistic programs. But one of the things that I like a lot about RoboDK for web is that if you have RoboDK for desktop, not either the trial version or the full professional version, you can create a simulation for your customer. Then you export it to the web version. You export it on our server, and then you can just send a link to the customer, and they can open, or customer partner, whatever, whoever, and then they can open it inside their browser, run the simulation, zoom in, look at the different parts, look at different solutions you are bringing to the table to solve their problems. or their issues. Yeah, it's something I like a lot in terms of the selling aspect of robotics and automation. Like you're sending a quote, but oftentimes those quotes are quite heavy. So you're kind of justifying, or you're bringing more argument to the table. There's this saying like an image is worth 1,000 words. Like when we talk about a full simulation with all the details and everything, for a lot of people, this is worth a lot. And oftentimes, like, okay, yeah, the guy you're talking to, generally like the technical guy, he understands the solutions that you're trying to propose, or at least he has a good understanding of like what's going on. But the person that is actually like signing the check, he might be higher up in the hierarchy, and he might not have any technical understanding or knowledge. Maybe some understanding, but not necessarily like deep technical knowledge. So having that kind of simulation video, if I can say, because it's more than just a video, you can really like get into the station, run the program, run the sub-program, zoom in, zoom out, play with the robot a bit, change the little details. So that might be something that will help the integrator sell the solution, and also internally for the technical guy that want to have that solution to solve the production issue they have, be able to sell that to their upper management, the people that will actually like pay for the thing.
Yeah, it's interesting that it's a way for technical folks to make it more tangible what's practically going to happen when robotics are implemented. And it's interesting that RoboDK, especially with the web version, is moving into much more of a multi-user landscape. And I was wondering how that goes, because from knowing software, if you have one person and then you move it to two people, it's not twice as complex. It's 5,000 times as complex.
Yeah.
So what have the practicalities been there? Like, is there version management? Is there like, if one person makes that update one place, how does it propagate to other places? How's that going so far? Since this is a new switch. I feel like
you read our roadmap for the future.
Okay.
So we're not there yet, honestly, because right now we are more focused on like one or two users working on the same project. But I noticed, anyway, side note, I'm also teaching here at the University in Montreal, robotics and automation. And because of COVID, I had to go to remote teaching for a few semesters. Thank God now we're back to presential, and then with all the robots and all the good thing. So the point is I had like teams of multiple students working on the same project, and I quickly realized that it was not necessarily like the easiest to do. So since then, RoboDK for Web is like one step towards that, but like we are really working towards a way to have, let's say, people working on smaller substation, let's say in an assembly line, and then being able to merge them together. I can't give you a timeline of when this will come out, but it's funny because we had a discussion regarding that like this morning in our tech meeting. So this is something we're working on right now. Because as you just mentioned it, like as soon as you add more people to the mix, it gets much more complicated. Like, and I think that we all saw the difference when like Google, let's say, came up with a Google spreadsheet or stuff like that, where you could have like multiple people working on the same file at the same time, which was the Google Docs that I was looking for. But like we really saw the difference in terms of like how efficient that could be compared to just having like multiple versions running around. So I'm not saying that we're going to reach that tomorrow, or that we're going to reach that kind of like efficiency or collaboration. But like we really see with that kind of example that there's a lot of improvement that can be done to the way software generally works.
Related reading for folks who are in software who are following along. One of the Google Wave engineers did like a series of blog posts on operational transforms versus CRDT. Absolutely required reading, as well as some of the blog posts from Figma's CTO on like multi-user real-time web development and stuff like that. So if folks, sorry, I'm like totally going deep nerding out, but like if folks are actually solving these problems, those blog posts are like worth gold for every word. So that's an aside. Awesome. This seems to be happening, like you mentioned, probably in education, but also in the business world, like between systems integrators and customers. You have such a long runway of like prove out and the ideation phase and the planning and all that stuff. What have you heard from the front lines of how people are managing these projects from inception to reality? Because these are long projects, and as you called out, they're high risk, and stuff like RoboDK hugely de-risks a lot of things in a really valuable way. But what are folks doing in the field to manage these complex projects with multiple parties and, like you said, someone else writing the checks? What are folks doing?
Oh, their best, I would say.
Yeah.
There's no magical formula here. There is no recipe for success. There's so many people involved, and like, there's so many challenges. I don't want to digress too much, but like we can just think about the fact that no one can get any parts these days, so that creates like a huge bottleneck for a lot of our partners. So using software like RoboDK for some reason, I'm like, yes, I will preach for our software, but using a simulation software in general is a good way to avoid having to realize, let's say in like 4 months from now, that you might need this part or you might need this other thing that will have maybe a lead time of like 26 or 30 weeks or something that is like completely unreasonable for your project. I think it's like before, people were simply like trying to do 3D models in SolidWorks or other CAD software, or even just 2D sketches to try to convey their ideas to the upper management with varied level of success, depending on how tech savvy or willing was the upper management, depending on the company. Like there's companies that are like deeply involved in robotics or automation and have been forever. Like you can look at the automation industry, like they've been built on kind of automation and assembly line or like and moving line, stuff like that. So there's companies that have been willing to take that risk. The things like with software like RoboDK, what I think it really like get us to is like for smaller or small and medium-sized businesses to make the step and to have like that comforting visual that like the process they are doing manually right now can indeed be robotized or automated depending on the process. So that will be just like a kind of a comforting vision, something that they can sleep on and really like kind of get their head around. And okay, like I'm not just signing a blind check. Like these guys have an idea of what they are doing. Like the solution that they're bringing to the table makes sense. Let's see if they can execute, because like, obviously a software like RoboDK is not the key to everything. Like there's still some execution that needs to be done, but it will prevent you from like one thing that I often come up with is like, it's like if you don't do a proper reach study, like before you actually like bolt your robot in the floor, like you might realize, okay, you're gonna like, okay, I'm gonna bolt it here. I'm gonna like add this, let's say tool, like this gripper at the end of it. And then I'm going to pick the part from here, put it in my machine, and then pick it out when it's done. Okay, that seems pretty simple. Okay, you realized after like you create all the program and everything that you are missing, I don't know, 2 inches, like something stupid that you would never have like realized just by looking at the size of your robot and then the floor plan and stuff like that. Right? Okay, I need 2 more inches. So now you have 2 choices. Either you unbolt the robot and then you do all the changes that comes with the base and everything to move it like maybe 2 inches that way, 2 inches that way. Maybe it will work, maybe it don't. Maybe you will just like add some kind of extension between the flange of your robot and the tool, but will you now have some collision or interference between the door of your machine and then the newly designed tool? This is all the kind of thing you can kind of prepare for and foresee before actually like building the physical equipment. It's a good way to iterate through solution much faster. Like you can, it's super easy in simulation software to just like move 2 inches to the right and test if it works, and then move to 2 inches forward and see if it works, or attach your gripper like they're floating, or like I said, I like to call it like with Wi-Fi brackets to your flange, so that you can see if I put it like 10 centimeter away with 20 degree angle with respect to the robot flange, will it work? You try to run the program, it does fine. You can now just design your small attachment between the flange and the tool and the gripper. If it doesn't, you open like one little text box, you switch that to 25 degrees instead of 20 degrees, and then you test it out again. You don't need to recreate the whole program because the position in space for the simulation software didn't change. You just change the position of your TCP or tool center point and the way the the tool is attached to the robot, and then you're ready for another iteration of your solution. That's a good way to test a bunch of solution in a really short amount of time. Like, yes, we like fast prototyping, like 3D printing and stuff like that, but that's even better. Like, if you don't have to go and actually build the thing 20 times to get a proper result.
So a lot of what you just described is interesting because it's like eliminating blind spots for people. But I'm curious about how much use are you seeing for greenfield projects versus like they're iterating on something that already is, like in software, we have this concept of staging and production. You know, like you'll have all of your stuff deployed on some kind of a staging server that users aren't going to, and you can test stuff and you can make sure stuff doesn't break. And then if everything's good and everything's vetted and tested, then you push it to production where the users are, right? But in robotics, in the world of atoms, not bits, you can't construct a second factory unless you do it virtually, right? There is no physical staging environment unless you have like a test factory, a small one. So do people use RoboDK for that, to test iterative changes on an existing process?
From what I'm aware and from the customer and users I'm talking to on a daily basis, most people work on brand new projects.
Just because cobots are only upticking now?
It's not just because like cobots are part of our market, part of our user base, but they are not the user base. Like they represent, I don't know. I can't tell you a number. It might be 30, 40, 60%. Doesn't matter. The point is like,
it's not the whole thing.
we have like, it's not like 90% cobots and like 10% of the rest. So we have a pretty balanced user base between the different robot brands. Now we know that more and more robot brands come up with cobots of their own. So like everyone pretty much is doing cobots these days, and most of them are doing industrial robots or standard robots, if I can say. So the thing is like the reason I see personally is like there is just so many new projects around. So I was talking like a few minutes ago about small and medium businesses. I think this is where a bulk of, I wouldn't say necessarily the number of robots are sold, because like obviously a GM or Ford will buy like, I don't know, like 100 robot in one blow. So that will eclipse like a bunch of small and medium companies that will try to get into robotic. But on our end and our like kind of customer base, most of them are fairly new users of robots. And this is a pretty cool thing for all of our users in around the world, but like in the US, in Canada, in Germany, France, and stuff like that, like more developed countries. Like it's cool to see that more and more smaller players are trying to be more competitive with robots, trying to compete with markets where maybe labor is a bit cheaper to come by. And that would be generally like a weakness for, let's say, more developed country. But instead, they say, okay, like we want to keep ownership of our high-end technology. We don't want to ship our high-end technology or high-end knowledge abroad for many reasons. There are reasons I'm not judging. The point is like, it's very cool to see that they are realizing now that like, okay, maybe having a robot do that repetitive job that like, honestly, the guy that's doing it should be saying like, I'm not a robot, I shouldn't do that, be able to do it. That's really where I see the market going right now.
So it's interesting that RoboDK, it seems almost kind of like a forcing function for learning. So it's not like RoboDK is, you know, a book that you read. Like I would recommend actually people read Lean Robotics for like a good, very cleanly laid out dissection of what are blind spots you might have about robotics. But it's like a forcing function for it. It's like a practical one. Like if you have to create a simulation of it, you have to realize that it's going to bump into something, you know? But it also seems like there's probably opportunities for RoboDK as a company to do education around things like that, since you are so familiar as experts about the blind spots.
The thing is, I do agree with you. I do believe that a simulation software like RoboDK is an amazing way for anyone to learn about robotics. For many reasons. Obviously, like I just mentioned, you don't need to have the expensive material that most people cannot like get access to, or if they get access to it, it will be like for a very short amount of time in a very curated setup. Like now you can just like pop that up on a very basic laptop that you have at home and then start figuring out how robotics work in general. Like if there's one thing in the field right now, is like we have much more demand that we have people ready to execute robotics. Like I don't know anyone around me in the field of robotics that is not like overbooked right now. Like if there's people that are, let me know. I'm pretty sure I have someone somewhere that was looking for to hire you. Anyway, the point is like there's much more demand for robotics that there's people that know about it. A software like that will help you. Like I was mentioning, like iterating through solution for a given customer, also iterating through solution and your own knowledge, like how does a singularity works, what's causing a singularity. Like, okay, yes, I'm hitting a singularity, or the controller tells me, like it gives me an error, okay, I read the error, okay, you're too close to singularity. What is this? Why am I close to singularity?
Singularity meaning, sorry.
Real quick. So singularity is trying to make it quick. It's like kind of a mathematical / mechanical void in robotics. Like generally it's caused by joint 5 reaching 0 degrees, so where J4 and J6 will be aligned for some reasons that would take a bit too long to explain. Yeah, both motors would need to turn like infinitely fast in opposite directions.
As soon as
you talk about like infinite speed with a mechanical equipment, it's pretty much impossible. And also, as if joint 4 and joint 6 are aligned, it creates an infinite amount of possibilities for the tool to be at a certain point, because like it could be like J6 minus 1 degree and J4 1 degree, and then you could go for J6 2 degree and then J4 minus 2. So like mathematically speaking, there's an infinite amount of answer to that, let's say, equation. So that causes a bunch of issues. So there's 3 different singularities. The one you're more likely to hit is the wrist singularity, the one I was describing. Otherwise, you have the elbow and shoulder singularity. So we oftentimes define the robot arm with like body parts. So we have the elbow with the shoulder, which is J1 and J2 together. J3 will represent the elbow, and then J5 and J6 will represent the wrist.
Cool. Very interesting, actually. Yeah.
So I'm just like, I will release 2 videos, in fact, on singularities in a few days on our YouTube channel. So this will be clarified. Half an hour of clarification versus like the last 30 seconds I did. It's much more.
No, but I got what you're talking about. It's cool. It would like flip instantly. You can't do that.
It doesn't work. Like it doesn't work at all. But like this is something like when I'm teaching robotics I'm trying to explain that, and honestly, like I'm always saying to my students, like there's 2 sounds that you don't want to hear in robotics. Like one is bang for obvious reason, and the other one is like you have a whir, like which is when like those joints will ramp up real quick because you're going near singularity. So if the tool want to keep its a constant velocity, it has to ramp up joint 4 and joint 6, and you will hear it. And Jerry, this is not a good sign. You try to stay away from singularities as much as possible. They will affect, like I said, the speed at which the tool can actually travel with respect to the part. So depending on the process, this can be not a big deal or the end of the world. Like if you're doing like stuff like welding or dispensing, stuff like that, those type of applications are very like the speed at which the tool like travel is super important. So yeah, there's a bunch of ways to avoid singularities. But yeah, this is not a robotics class here, so
no,
I don't want to go
I've been
too
curious
much
about this though. So I know about the concept that a robot can be programmed wrong and smash itself into a table and break itself, right?
Yeah.
How often does stuff like that happen? Like if a company is doing their first deployment, is that like for sure that's going to happen like 2 or 3 times during them doing it? Or?
I would say that we try to avoid it, and people are generally good at avoiding it by simply taking their time. So this like there is a simple button on your teach pendant which controls the speed at which you can either jog or run the program you just programmed. My first recommendation would always be like the time you think you will save by going fast when you're testing the program, you will waste 100 times if you ever smash in anything. Like if you break something, if you get your mastering off because of the impact, there's a bunch of stuff that can go wrong if you ever have a collision, stuff that you for sure want to stay away from. So like moving slowly but surely and then testing there's no shame about testing your program at 5% and then doing another run at 10% and then doing a third run at 20 and then ramping up until you reach the wanted speed or wanted cycle time. So there's no shame about that. But I don't think you can find any robot programmer that has, say, more than a year of experience that never smashed a robot. Like, at least like a small impact. This is something that happens. I think that if you're lucky, the first time it happens, there's no like consequences, and then you really realize that you need to go slower and you need to make sure that when you're moving, let's say in Z plus, you're not moving in Z plus with respect to the tool, but with respect to the world, so towards the top and not towards the bottom. So this is kind of small issue that can occur. Okay, let's say my XYZ coordinate or reference was at my TCP and the Z plus was pointing downwards. But then my world reference frame was pointing the other way around, so the Z plus was pointing upward. So I was on my teach pendant and I just wanted to do like a 10 millimeter motion up. But then I realized I didn't set up my teach pendant properly, so I was moving with respect to the tool instead of with respect to the world.
The enemy gate is down for the Ender's Game fans.
Yeah. So instead of moving upward as I was expecting, I moved downward, and it always happened 10 minutes before you were supposed to leave. Yeah, collision occurs. We try to avoid them. But it's part of the job. We try to minimize them as much as possible.
Okay, changing gears, pretty different question. You are robot agnostic, I think is the specific terminology you use. So all different companies that make robots, you have tons of them. You have a huge library of different ones.
Yes, we do.
How does that happen? And I saw somewhere that you said that like you were the one inputting a new one. So where do you get that data? How do you update it over time? And like, is it push versus pull? Is it companies coming to you and saying like, hey, we got a new robot? Or is it you like scrounging around and writing web scrapers of all these different, how does it work?
So yeah, that's a pretty broad question. That question. Okay. So step by step, like I do add some robot, but we have a team with us, and then we have particularly one employee, Oliver, it was like generally in charge of adding new robots. So the way it works is generally like a customer will come up with a robot they want to use. They will realize that it's not in our online library, and they will simply contact us. So that's the first step. Sometimes it's more like, okay, we know, like right now we know that UR is launching their new UR20. So we don't have it in our library because they didn't release the 3D models. They didn't release much. In fact, they did their announcement and everything. So they're more like in a marketing phase than they are in a like selling phase, if I can say. So as soon as they release the 3D model, we will add it to our online library. The way it works is pretty simple. Like for those who know a bit more about robotics, we need the 3D model, then we need to recreate what we call the DH table or the robot kinematic, which is pretty much a mathematical model. It sounds worse than it is. It's just like taking the measurements between the joints and then applying it into a small wizard that we have built in RoboDK. So for most standard industrial robot kinematic or cobot kinematic, we can do that in like a matter of 15 minutes. We can add a new robot. Otherwise, like if it's an older robot, from a known brand, but like an older robot, we will ask the customer to come up with the 3D model as a step file and then give us the user manual so that we can get those measurements, joint range, speed, where's the home position, and stuff like that. And we input that into, like, we have a small, like I said, a small wizard or like one pager where we can just like link all of this information, and then the robot is created. So we streamlined our process. When I joined RoboDK 4 years ago, we had, I believe, something like 350 robots. I was like, oh, that's a lot. Like, I don't think that we will add much more. We'll see like the new robots that are launched or something like that. But we have overpassed 600. I think that we're nearing 700 robots now, and we're adding new robots on a weekly basis, generally like maybe 2 or 3 a week, depending if there's new launches and stuff like that. Sometimes it's new robots, sometimes it's like very old robot that like one customer somewhere is using. So if someone owns a RoboDK professional license, we will add a new robot like within a week, business week, generally something like that.
That data set is rare and valuable. There's a ton of interesting things that you can do with that. One I saw on your website was like, you could stack rank various cobots based on like pitting on X and Y, like their reach versus their payload that they can handle. So that's really interesting.
We created a small robot picker, like where, like as you mentioned, like if you want to know, okay, I have like this kind of payload that I need to work with, and I would need approximately this kind of range, you can just enter those two, and then it will give you kind of a cluster of robots that are usable for your application.
Okay. But my guess is that that's not often like the primary driver of the purchase decision of which one you go with, because like a former guest that I had on said, like, if it can do the weld, it can do the weld, or that kind of thing. It matters more how it can maybe integrate with the rest of what you've got.
I do agree up to a certain point. Obviously, like payload and reach are like factors. There are parameters in what robot will be chosen. But obviously there's a bunch of other parameters. Like some people will need some clean room type robots because their application requires that. Some other will require the Foundry edition because they are working in a very, very dirty environment, and like a standard robot wouldn't last very long. Some people will need, let's say, and you can look at two robots. Okay, two robots will have a similar, let's say, reach, but a very, very different payload. Someone maybe is doing milling. The payload of the tool they are handling is, let's throw out numbers like 50 kilo, but they will take the 150 kilo payload robot. Why? Because it's much more stiff. So when they will apply pressure on their part, they will try to cut. The robot won't be as prone to vibrations and other issues that can arise if you don't have like a bulky robot. Like, yeah, some robots are there for doing stuff like inspection or painting, where you're just like moving a very small payload around, and like the reach is more important than the stiffness, and there won't ever be real pressure, real contact between the robot and the external environment. And in other cases, it's like constant contact with either assembly or, like I said, milling, where you're literally like removing material from a part. So if you want to be accurate in any way of form, you need to have something that is kind of sturdy. We can discuss about like later maybe a robot calibration and accuracy. This is another different topic that we do have solution for too. But yeah, this is something that we realize, like robot stiffness is very variable depending on, like even in the same robot brand, like depending on the model you pick, there'll be a big difference between this stiffness of one robot over the other.
From what I've heard, cobots don't last for forever. And I wonder if there's any affordance for like rated durability, or like, I don't know if they sell warranties with these to like, this is, covered for 4 years or something like that. What's that side of things like?
I don't know any tool in life that will last forever. So yes, obviously robots do follow this reality rule, if I can say. I'm not necessarily the right person to answer that question, like in terms of like how long the robots will last. And like obviously there is some warranties for robots, but like the thing is, the way you use the robot will influence a lot how long it will last. So some robots are in the field for decades and they will still run as smoothly as the first day. Yeah, well, you will have some like maintenance to do on it, like obviously, but other robots will be beaten to the ground in a matter of a few years, depending on what kind of application and what kind of work you're asking them. So it's the same kind of thing with your car. Yeah, your car can last like for 20 years and like run for 500,000 miles, and the other guy who bought the same exact car will have like a piece of trash in like 10 years and 200,000 miles. So it's really like how you use it that will define like how long it will last. It's hard to say for cobots like how long they will last, because they've not been there for a very long time in the first place. They're pretty new.
Just anecdotally in the industry, do some brands get a reputation for maybe not lasting as long as
the thing is like it's like I said, it's hard to say for the cobot world, because like it's a very new field, and like the brands that are there, like okay, UR is the oldest brand of cobot, and they are like 10 or 15 years old maximum. And they went through like 3-4 iteration of their robots so far, so they've improved over time. So like I would be more willing to look at the robot that they provide today and see like in 10 years from now, and like make an opinion for myself with those new robots. Like they are more mature now in terms of like the industrial robots, like the standard metal robot that we know about. I feel like that the brands that didn't know what they were doing, or they had issue are long gone. So like the evolve or die type of setup has already been done for like years. If you look at ABB, Kuka, Fanuc, Yaskawa, they've been there for decades. So like they know the thing. And like the other day I saw like a Motoman, now known as Yaskawa robot, like the Selman on LinkedIn was kind of bragging about the fact that it was the first robot he sold like 25 years ago and it was still going strong. So yes.
Pretty cool. It's cool though that a lot of the answers are like, well, this is also new. We'll figure it out. And I feel like anyone who's listening to the show, you're in the right place at the right time. This is growing and you're part of it, you know?
It is at an incredible pace, honestly. Honestly, at RoboDK, we have a hard time keeping up with the demand. Like, it's one of our main challenge, like making sure that we can answer everyone, that we can support everyone.
Now, along those lines, since they can see all of the potential things that they could purchase to solve their problems, I have to imagine that RoboDK plays a pretty instrumental part in the purchase decision of a lot of these companies. And that is extraordinarily monetizable. And it makes me wonder if like RoboDK might go more in that direction.
It's not our goal for now, because like if I just give you a bit of history about our company, like RoboDK started as a school project here. We have a research chair in Montreal for, by the way, we are in Canada, Montreal, Quebec. We have a research chair for robotics accuracy, robotic precision at ETS Montreal. So the goal is to improve the accuracy, absolute accuracy of robots in different ways. So at the time, like maybe mid 2000s, there was a few robotic simulators / offline programming, because like I said, we also do offline programming where we can generate robot code for your robot. But they were either brand specific, like Robot Studio for ABB or RoboGuide for Fanuc and so on, or they were not that affordable. I don't want to mention anyone. I don't want to throw any rock at anyone. Like they all do their business, but it was not necessarily something that most people could go in and, let's say, take their credit card all out and purchase, which is kind of our philosophy here at RoboDK. So this is why Albert, our founder, decided to start creating, and with other people at the lab, I started creating a simulator. At the time it was called Rocky Sim. Anyway, so, and the goal was to have a 3D environment so that what you coded in MATLAB, you could run into in that 3D environment, and then before running it onto the robot controller, instead of like just coding a bunch of, let's say, super advanced and fancy stuff in MATLAB, cross fingers for the robot not to crash into the wall and like run the program. So it was pretty much just a tool that was built to kind of fill that gap that we had as a researcher in that lab. But as time passed, we added more features, because it was just a API or code base software in the beginning. It was just a 3D environment, and then you were coding some stuff. But as time passed, we added more UI related feature, and then in 2015 RoboDK was launched officially. So our goal is still to have, like, we have two core values, like being multi-brand. So we absolutely want people to be able to use any robot, because like in the lab we were working in, we had some Yaskawa robot, we had some ABB, we had some Fanuc, we had some Kuka. So we needed something, and we later on we added some UR robots and other brands. But like it was imperative for us to have a place where we could do all of our work and export to all of those robots after, because calibration and robotic accuracy is not a brand specific problem. It's a problem that anyone can face. And then the other thing, like I mentioned, wanted to be affordable, because like some of the other simulator on the market that are not brand specific are sold for as much as a robot. So like for GM, they don't care. Like they will buy a few licenses of process simulate, let's say from Siemens, who, from what I know, can run between 100K and whatever much you want to pay for in terms of options after. But like most small to medium company, like they can't afford that, or they don't want to afford that. Like it's too much of a risk for something they never played with. Like if they want to get involved into robotics, they will already have to to pay a few dozen, maybe $100K for the robot and everything around it. So our goal is really to keep that as affordable as possible, so that people can get involved into the field. And honestly, just with that for now, we have our hand full. So we're not necessarily looking for other ways of monetizing our software. Like our partners are using RoboDK that way to monetize their business. And like, we are super happy to have a bunch of partners that we are enabling to do more advanced robotics, like we were doing when we were students in our research lab. So it's a tool in their toolbox. The robot is a tool. Everything they have around is a tool. RoboDK is just part of that toolbox for them to be able to create more amazing applications, more amazing work. Because like, as someone told me, like at some point, like if there's one standard application in robotics, that there's no standard application. Like it's always something custom. So you always have room for like testing stuff out a bit before you actually build it and press play for the end customer.
There you go. Well, beautiful. You've been so generous with your time. Really appreciate you sharing all this with us. Any advice for folks if they want to get in touch with RoboDK? Like I said, you can go to the website and try it out, but any other ways for them to reach out to the team?
Yeah, we have like one way that we really appreciate, like if you have questions, stuff like that, we have a forum that we try to be as active as possible on. So the community forum, honestly, we are the one answering most of the questions. We really like when people ask their question there, instead of sending us emails. Like we will answer to email. There is no issue. The thing is, like, we really like the fact that when I answer a question on the forum, I know that maybe like 100 more users will see the question and the answer. So instead of something like an answer that will kind of die in someone's inbox somewhere, like the person will be satisfied, will have the answer, but that's it. I prefer like spending, I don't know, like half an hour creating like a very complex and complete answer to a question and trying to add as much substance to this answer, so that like when I go and see like an answer that I answer a question, sorry, that I answered, like, 3 years ago, and then I see like, I don't know, there's like 500 view on that question, like that's something that we really like. Also, like I mentioned earlier, we have a YouTube channel that we work quite hard on. We try to put as much training material there so that people can learn on their own, at their rhythm, because we all know that we all have like super busy schedules, and you can't really like sit down for a week in front of a trainer and learn a new software. You already have like a bunch of other appointments, responsibilities, stuff to do around. So people can just take, I don't know, like during their coffee break in the morning, 15 minutes, they watch a small training video, and then they go on with their day. They use the software, and then they have learned a few new tricks. So I try to put as much material there, and obviously our website is there to help you otherwise.
All right, great resources. Highly recommend everyone checking out those YouTube channels. All right, thank you so much, Jérémy, for joining us.
My pleasure, Kevin. Have a great one.